Colin Maclaurin was born in February of 1698 in Kilmadon, a civil parish situated on the Coal Peninsula in Argyll and Bute in Scotland. Maclaurin was a Scottish mathematician who extended Isaac Newton's work in calculus, geometry, and gravitation. He was a child prodigy. Maclaurin was such a smart child that he entered the University of Glasgow at the young age of 11. When he was only 19 years old, he was elected to be a mathematics professor at Marischal College in Aberdeen. Just 2 years later, he became a member of the Royal Society of London, the oldest national scientific society in the world and the leading national organization for the promotion of scientific research in Britain. It was at this time that he became acquainted with Isaac Newton. During this time, Maclaurin developed several theorems similar to some of Newton's theorems in Newton's Principia. He also introduced a method of generating conic sections that is known by his name, and described that certain types of curves can be described by the intersection of two movable angles. In 1725, he was made a math professor at the University of Edinburgh. Maclaurin wrote his two-volume treatise of fluxions, a defense of the Newtonian method of calculus, in response to Bishop George Berkeley of England's allegations that Newton's calculus was founded on poor logic. This treatise is important for many reasons. It for the first time gave the correct theory for distinguishing between maxima and minima, which emphasized the importance of the difference between different points on a curve. On top of this, it includes an extensive description of infinite series, notably the specific Taylor series variation, which is currently named after Maclaurin. When Jacobites, supporters of the Stuart king James II and his descendants, marched on Edinburgh in 1745, Maclaurin played a key role in building trenches and barricades to defend the city. Maclaurin escaped to England as soon as the rebel force conquered Edinburgh. His health was destroyed by his escape, and he unfortunately passed at the age of 48. A Maclaurin series is a power series that allows one to calculate an approximation of a function f of x for input values close to 0, given that one knows the values of the successive derivatives of the function at 0. In many practical applications, it is equivalent to the function it represents. An example where the Maclaurin series is useful is the sine function. The definition of the sine function does not allow for an easy method of computing output values for the function at random input values. On the other hand, it is easy to calculate the values of sine of x and all of its derivatives when x is equal to 0. The Maclaurin series allows one to use these derivative values at 0 to calculate precise approximations of sine of x for inputs close to but not equal to 0. The Maclaurin series is used to create a polynomial that matches the values of sine of x and a chosen number of its successive derivatives when x equals 0. The resulting polynomial matches the sine curve closely.